The opening address was given by Ivor Owen, Director of the Design Council, introduced by Professor Bramley. The projects you're about to see were tackled by groups of 10 students. I asked Mike Waite, Chief Engineer of Equimed, to describe his team's project.
Can you tell me where you got the idea that there might be a demand for an equine ambulance from?
Well, in 1987 there were 205 equine fatalities in the flat and national hunt seasons. Many of these fatalities could have been avoided. It's not a medical problem, they can be treated. The problem is to get them off the horse within 30 minutes before the next race comes along. Now at the moment there's no vehicle available which will humanely get them off the track. The only option is at the moment to shoot them and drag them off.
So how does your equine ambulance work then? What are the basic features of it?
Basic features, we cater for 2 occasions. A severely injured horse which will be presumably lying down and anaesthetised. We can transport that with a mobile trolley onto the vehicle using a lift, and once on there we can take it for a journey of perhaps up to 4 hours, administering anaesthetic and carrying out minor operations such as sewing up lacerations, things like that. Also a standing horse, we've catered for that as well, so that any minor injuries we can transport it to a veterinary centre with causing it as little distress as possible.
Rachel Crocker, you're Chief Engineer on a project that produced a container cutting system. Can you tell me what sort of containers your machine is designed to deal with and how it works?
Right. The containers are food packaging containers to hold food during transport and over 12-month to 24-month periods.
So it'd be tins or?
To replace tins. They are made of a high barrier plastic. It contains approximately 80% polypropylene, which prevents contamination from the environment or from during transport.
So quite a topical project at the moment then.
Yes, well it's a high product market with 6.5 billion tins being used every year in the UK alone.
I understand your project's actually sponsored by someone in industry as well, is that right?
Yes, it's sponsored by BXL, which is a subsidiary of BP,
Right.
which have asked for us to look into their problem, which is the last part of a 3-part process, which extrudes the plastic, moulds the plastic, and then finally cuts the plastic. Now, we were looking into the final, very critical area of cutting the plastic, where we require high-quality cut, high accuracy and high concentricity, 100% of the time, to ensure a tight seal on the double-seamed lid, which goes around the flange when the food is inside, to ensure that no contamination can occur.
So does it look like this machine will actually go into production? What's the next step?
Well, the next step is a further research project, sponsored again by BXL, we hope to do within Bath University itself, to further the detailed design and ensure that it will be part of the 3-stage process.
So it's quite likely that part of the machinery you've designed will go into a real product?
Yes, it's very, very likely.
That's excellent.
So, great.
Well, the Chief Engineer from Eurosim is Phil Smith. Now, Phil, your project is a simulator here.
That's right.
How does it differ from a conventional pilot training simulator?
Well, we had to aim at a much cheaper market, really, because a flight simulator costs of the order of £5 million to produce.
So this isn't for training pilots?
No, no. The other thing is that with 15 passengers, it would be very difficult to have an active simulator where everybody would have a choice as to which direction the car would go into next, or the aircraft.
You'd end up with an argument, backseat drivers.
Therefore, we've designed a passive simulator.
Right, OK. So what market are you aiming at, then, if you're not aiming at training?
We're aiming more at the leisure industry. We're looking to install these in exhibition centres, various places like these, where it'll be a focal attraction or possibly just a sideline.
Right, so what will the features of the ride be for someone inside? How will they actually feel themselves moving?
Well, the simulator is able to move in 3 degrees of freedom. That's heave, which is just up and down.
Right.
It's also able to move in roll and in pitch. And with these 3 movements, we can recreate the sort of motion feeling inside with the sound and vision cues that are required to make you feel as if you're there.
So Phil, what sort of market do you think there'd be for this device? How many of these do you see there being around the country in 10 years' time?
It's a very difficult thing to say simply because they don't exist in large numbers just at the moment. But we would hope that with a payback period of about a year, these things would become quite popular. The trouble in the leisure industry is that people very quickly get bored of things that exist, and so they have to be updated and improved very, very quickly.
But with a payback period of a year, you hope that people can restore their
That's right,
capital
yes.
before they've
Yes.
the fad's moved on. That's interesting. Thanks very much, Phil.
Thank you.
Well, just along from Eurosim is Translock, which is a slightly different kind of project. Now, Julian Gorniok is their chief engineer, is that right?
That's right, yeah.
Now, tell me how this project differs from the other projects we've seen so far.
Well, the other projects around here are mainly interested in focusing on a product and looking at the engineering of that. We choose a product, but then we go ahead to design the business in which to produce that product. So our emphasis is on the design of a manufacturing business.
The wider
really.
aspect of
That's
the
right,
engineering
yeah.
of it. So what is the actual product that you're dealing with, engineering?
Well, the product is called a Translock anti-rollback device. Basically, it's a device which prevents a vehicle from rolling backwards on a slope by means of a Kevlar belt here, which wraps itself around this drum fitted to the drive shaft and holds the vehicle on an incline.
Now, is this a real product, Julian? Is this actually in production? Has someone come and asked you to design a system to produce it?
Well, that's right, actually. This product exists already. The company that made it was a very small firm based in Sheffield. When we got in contact with them, they were at the stage where they needed a design for a manufacturing plant that could handle the large volumes that they expected to sell for this. So we've gone ahead and designed the business based on £2 million venture capital that would be able to handle the kind of volumes that they'd be expecting in the future.
Right. Right, well, the development of airports near and in the centre of large cities has led to a new requirement for aircraft, I believe. And Dave BEng has been chief engineer on a project to design an aircraft specifically for that purpose. Is that right?
That's right, yeah.
Dave, tell me a little bit about your aircraft. What are the requirements as opposed to designing something to fly around the whole world?
Well, the aircraft is designed for the London City Solport in the Docklands, and it's generally used for commuter flights around Europe and also inside the USA. The main restriction on the design was the field length that we could operate from.
So that's the runway length?
That's the runway length, yeah. But this aircraft exhibits cruise performance of large jets, but it also retains the short takeoff and landing performance required for the runway length.
That's great. Right, well, Steve Brady has actually provided a bit of competition for the aircraft design that we've just seen. Now, Steve, I gather that this is fairly similar to the HPS 400. What are the main differences?
Well, we've both got the same specification, except that we elected to choose turboprops, whereas they've chosen turbojets.
So what are the main advantages or disadvantages in doing that?
Bearing in mind that we're designing the aircraft to operate from the London Docklands airports, noise requirements is a big factor. Turboprops have been proven to be more economical, but also quieter, which is a major emphasis. Performance as well, they're highly advanced blades and they give us the thrust required to take off in the short runway, whereas modern aircraft would have to extend the runway if they operated from Docklands airports.
London's business community will benefit from fast travel designs like those you've just seen. From the modern-day aerospace industry, our next project is applied to a more leisurely mode of transport. The Kennet and Avon Canal features many locks, and while pausing to navigate them can be an enjoyable part of a holiday, a flight of 29 locks would take a day to pass. One stand at this year's design exhibition illustrated a new way of raising and lowering narrowboats without spoiling the environment. It uses a pressure vessel which is floated up or down through a caisson, a column of water, to the new canal level.
Well, not everybody uses narrowboats, but everybody uses the posts, and something Bath is famous for as well as its canals. Colin Holmes is part of this group, Packman Presentation Pack Manufacturing Systems. Tell us about the product you're manufacturing.
Well, the post office sells stamps to philatelists in presentation packs such as these. Basically, the stamps commemorate different occasions and come with a backing pack and a pack on the top here which carries information relating to the stamps and the various artists who may have been involved in creating them.
So what part of it is it that your machine manufactures?
Well, basically it's the backing board, which effectively looks like this. It's cardboard
Right,
with a Melanex film on top of
On top of it, right.
which forms pockets into which the stamps are placed,
Okay,
like so.
okay.
Well, basically, Melanex film comes in the machine at the front end here on a roll. It's fed through these rollers into a gluing station. Glue is applied there. It's a heat sealing glue. The next stage is a card placement system. Pre-cut card is placed onto the film and laminated in the next set of rollers. The two are then passed through a slitting station where the pockets are placed into the products. The final stage is a guillotine unit which trims the leading and trailing edges before stacking them up for an operator to remove.
Students at Bath also produced a device for inspecting underwater spent nuclear fuel elements before they're reprocessed at Sellafield. This special powered wheelchair allows disabled people to travel on soft sand. All these large team projects were eligible for the Small Piece Design Prize. Each year a panel of 3 judges, usually fellows of the Small Piece Trust, assess each of the projects. This year they awarded joint first prize to the container cutting system and the machine for producing postage stamp display backing boards. The machines you've seen so far were produced by groups of 10 students. The mechanical engineering course at Bath also features 2-man design projects. I asked Steve Denny to explain his project.
It's a food pack leak detector. It's a device for detecting whether a pack is a leaker or not.
So what sort of packs are we talking about here? What kind of food will be packaged for this machine?
Here's some typical type of packs that we've been using or detecting.
Right, so that's fish and bacon that we've got
there's
there.
fish here and bacon. It can be liver, kidney, anything like that.
So I gather that it's not just a plastic box with the food inside, there's something else in there as well, is that right?
Yeah, these containers are filled with an inert gas mixture, and that's to increase its shelf life. And we're finding the problem is at the moment about 5% of these have holes in them, and they're getting onto the shelves and they're reducing its pack life. So you're getting rancid packs on the shelves.
Right. And is there any system currently that can actually detect these leaks?
No, there isn't. This is the first.
Right, so there's a potential good market for this then?
Yeah, the device has been patented.
Right, okay. And it's actually going to go into production with Porter's Engineering, is that right?
Yeah, they're going to do some more tests on it, and hopefully it'll go in production.
Fantastic. Well, earlier on we looked at a project that was designed to help with Magnox nuclear reactors, and I believe that this project is something to do with the next generation advanced gas-cooled reactors. Rob Garrett is one of the designers. Tell me about the project, Rob.
Well, this piece of equipment is used at Berkeley Nuclear Laboratories. What it basically involves is studying the flow down the length of a nuclear rod, as we've got shown here. Along the length of the rod, we have several pressure tappings. But to be consistent in taking readings, we only have one piece of measuring equipment. It's therefore necessary to take those 25 inputs and put them through some sort of valve mechanism and only take 2 outputs for the pressure transducer. The piece of equipment which we've built is the switching device for that.
Right, so basically it sniffs along at 25 different points.
Yes, it goes along about sniffing every 10 seconds.
Right, okay. Right, well, another product that's used by the million is rivets every year. Now, this machine doesn't produce rivets, but Mike Hook here, together with his partner, has designed a machine that actually produces the things that rivets are made on. Is that right, Mike?
Yes, this is the high tensile steel mandrel on which a number of rivets are placed. And we have a riveting gun which places the rivet on there, then pulls the mandrel through the middle of the rivet.
Right. And that actually forms the rivet so it holds 2 bits of metal together, does it?
Yes, that's correct.
Right, okay. So what's wrong with the conventional method of manufacturing these mandrels?
Well, the trouble with the method at the moment is that they start off with wire of the head diameter, then do a process on it called swaging, which reduces the diameter across all this length and just leaves the tiny head on the end.
So they stretch it, basically, do they?
Yes, that's right.
So is the machine that you've designed actually going to be used in production, Mike?
Well, this is only a prototype machine at the moment, but we're hoping that a modified form of it could be used to produce the actual mandrels.
Well, the next project that we're going to have a look at is, paradoxically, finding a new solution to an old problem. Julia Ralph has been working on it. Julia, what is the problem?
Well, the problem is that these
sealing clips are being reintroduced, and at present they're attached manually.
This is for beer bottles,
This is for beer bottles. And because the company, it's Devenish Brewery, that make this beer, are increasing their production, they want to automate the system. Now, there's a system that attaches the clips to the bottles. So our system is to feed the clips at the correct spacing and feed rate to this system.
Right, so they're quite awkward things to handle, aren't they, these clips?
Yes, because they're not a very good shape. Yeah.
So is it really a change in consumer demand which has led to the need to produce this machinery?
Well, yes, they're hoping to sell these bottles abroad, in which case their production will increase quite considerably. So therefore they'll need a system to obviously reduce the costs, as well as it's very tedious in attaching the clips by hand.
Well, Nigel Taylor is Chief Engineer, is that right, for the project which we're looking at now, which is a stock replenishment communication system. That's a big word, Nigel, big title. What basically is the project about?
This is actually a two-man design project, and it's basically concerned with the data communication system between two areas in an engine assembly factory.
Right, OK, so why should you need to do that?
Well, with this particular area of the factory, there's a need to keep a stock of pistons and common rod assemblies in one area where they're actually stuffed into the engine block. Right. Now, to keep this stock at the right level, you have to have a communication system between the area where they're kept and the area where they're assembled, so that they transfer the right sort from one area to the other.
Fine, well, I believe you've actually got a piston here, so perhaps if you can give us a demonstration. What does the pallet look like that it goes into?
The final solution pallet
is like
so.
Right, OK.
And it's coded in colour and with a number to tell the operator what should be on it and effectively what is required back at the other part of the production line.
Fine, OK. Now, I gather that this system is actually going to be used in practice, and it's a sponsored project, is that right?
Yes, it's sponsored by the Ford Motor Company and will be installed within a few months into the BEng engine plant in South Wales.
Another project led to a new window closing and locking system. Designed for Secura style, the company planned to add it to their range after further development. The last of the two-man projects investigated a shape memory alloy latch. It's needed to protect sensitive equipment from the high forces and vibrations experienced when satellites are launched into space.
Well, we hope you've enjoyed having a look around the 1989 design exhibition here at the School of Mechanical Engineering. It's an exhibition that's sponsored very largely by industry, designing real products for real markets. If you're interested in taking part in this sponsorship scheme, the man to contact is Derek Bradford. See you next year.